So this presentation, 15 ways to optimize Spring Boot for the cloud. So kind of initially when I had the idea for presentation, like, yeah, I could get 15 ways. But over time, I've actually added to them. So it's actually now not 15 ways, but 18 ways to optimize Spring Boot for the cloud. So you're actually getting 20% for free. So it's a pretty good deal for your typical presentation. So Mary is mentioning Java Op Heap, and that is a fantastic podcast. I actually pretty much listen to it whenever an episode comes out, and it's a good way for me to keep current on it. And actually, I also kind of feed that into, so there's a Java newsletter that our team, Mary, myself, and a couple other members of our team put together to write. I actually recently wrote our July newsletter, kind of covering some of the recent things the Java community has been working on, even though we've all been kind of sheltering in place because of COVID, but it's a good way to kind of keep up. We send it out usually monthly to kind of keep up with like what's going on in the world of Java. All right, but interested in what does Spring Boot mean, or what does it mean to optimize Spring Boot? And so the first big thing is like our two important things is that, well, for one, you're never going to get something just optimized. You're never going to get to a single point to saying like, it's all optimized, we're done, we don't need to do anything else. Optimization is going to change over time. So it's going to be a goal that you're probably never really going to ever get to. It's a very dynamic thing. And then also, as you see that there's other goals, there's not just a single factor you're typically going to optimize on. There's a lot of different factors, considerations when it comes to optimizing, and which one you care about is going to, of course, vary depending upon your organization and also the application you're trying to optimize. So what are some factors for optimization? Well, I think actually one of the first factors you want to consider is observability. Only through observability are you going to actually be able to determine, is this application working well? Any changes you made, is it a change that's actually helping the application work better? Is it working worse now? So in many ways, I consider observability kind of like the first most important factor in optimization, because kind of the scientific way of like, you can only know if you're doing something right, if you can test it and then good results back. Another factor is resiliency. So if your application is frequently crashing, if it's sending a lot of errors, or it's just not behaving very slowly, well, that's not going to be very good. You may be using very little resources, may be very CPU efficient, you may never truly fully crash, but your application may not be that usable, and ultimately, no other optimization factor is going to really matter if no one can really use it. So your application up and running all the time is another really important factor. Getting as high of availability as possible is going to be more important probably first, then maybe saving a little bit on CPU, memory, or other resources. Scalability. And scalability works in both ways. You need to be able to scale up very quickly when you have a whole lot of demand, but then you also need to be able to scale down very quickly as well when that demand drops. And you want to be able to do that, again, as quickly as you need to, because if you take a while to scale up to meet demand, then that demand may not be there by the time you actually scale up, or you're just losing a lot of potential clients or customers or business because you're not able to meet that demand. And then also by the same token, if the demand drops off, you may be spending a whole lot of money from all those resources for all the demand that you're not actually needing to use or meet. So scalability is important to look at from both the factors of going up, but then also going back down. Security. That's another really important thing. I'll talk a bit more about it later on, but still, even though it's a few years on, one of the biggest hacks that we kind of remember is the Equifax hack, where a huge amount of credit information and personal information was stolen from Equifax or leaked by Equifax. And that happens a lot of time. And a lot of times the security kind of happens from underlying layers. So it's really important to be optimizing that, because if you're losing a lot of client data, you may be subject to lawsuits, as Equifax has been, or of course bad press. And it's just, again, not good. And what's important as developers, we kind of have an important obligation to hold our customer and client information in trust, because that can actually be used to cause real harm to people. People can have their identity stolen or have other information they don't want to have released out there, depending upon what sort of confidential information that you have. Of course, efficiency. That's probably something really what me and people are kind of first thinking when they hear optimization is like, how can I be the most efficient possible with the CPU usage? You know, how can I use less memory but still service the same number of requests? So of course, that is of course important and something we'll talk about as well in this presentation. And of course, that all relates back to money. How can we do more for spending about the same amount on hardware or cloud services? And finally, improvement. We need to have a good system in place to where as we make changes to improve the optimization of our application, that we actually know the changes that we're making. If we are having a very clunky and difficult release cycle, it can be very difficult to know to like, oh, I'm going to make a little change right here that might have like a 1 or 2%, memory savings. But if you're including that with thousands of other changes, it can be very difficult to know, did that change really help? Or you may not even want to make that change at all because it just increases your risk for maybe not so much of a reward. So there can be good ways of kind of setting up a culture of improvement to allow these real actual optimizations to take in place. A lot of this presentation kind of comes from several books. I'm not saying you have to go out and get all these books and read them right now, but they're definitely good books to read at some point. Like I said, if it's over like the next 5 years, don't feel like you have to go out and do this all right away. But domain-driven design, whether you're doing, particularly if you're doing microservices, is really good. But even for monolithic applications, it can be good for kind of architecting your application, finding the different parts of the application and where they should reside. One of the big bounded domain contexts, I believe, is what it was called in the book. Kind of gives the contours of like the different objects and concepts within the organization, and then also, of course, making good code that's kind of readable by actually like instead of just having very abstract concepts in your code, actually having the concepts relate to your business, meaning it can help it with its readability and understandability, which can, again, make it easier to optimize later on. Continuous delivery. If any book kind of has had the most impact on my career, I would say it's this one. It's very much about how you can set up automated ways of delivering code to production. And before I became a developer advocate, or really the first place I worked at in my professional career as a software developer, it was a very manual process getting to production. And it was very slow, it was very error prone, and it was just very difficult and labor intensive. And we tried a lot of other things to address this, or address like our problems with code. And like we tried like re-architecting, we tried using the latest software, or like Spring at the time, like just like Spring 2.5 or 3.5 at the time, but never made a much difference. But continuous delivery and actually really automating your delivery pipeline can really make a huge difference because it makes it much more repeatable and much easier to get to production. Also, Release It is another really great book for building kind of robust, and as the book name says, production-ready software. And there's a couple really important concepts that kind of were popularized by the book. And it was actually a newer version that was released 1 or 2 years ago. So I would recommend picking that one up because there are also a couple of things in here that are a bit dated as well. Like, for example, it talks about JSPs, which aren't too heavily used anymore. Also, finally, a couple of my friends, Josh Law and Kenny Dasani, who I'm sure actually both, I know Josh has definitely spoken in CJEC. I'm pretty sure Kenny has also as well. They wrote a book a few years ago, and they actually take a lot of elements from each of these different books as well. And it's, very much also Spring Boot centric. So I definitely also recommend checking that one out as well. All right, let's actually get into these different 18 factors. And I'll try to get them through them pretty quick just to make sure, we're not getting too late into the evening in this, because I know people probably also want to make dinner and everything. So the first is, a lot of times organizations, when they're considering moving to the cloud, like there's idea that we have to like re-architecture and do everything different and like go to microservices. I think when I kind of first did this presentation about 1.5 years ago, microservices were kind of maybe right at that very top of like the hype train. I think it's kind of starting to come down a bit. I think with good reason, but yeah, you don't have to be microservices to be on the cloud. You don't have to completely re-architecture your framework to be on the cloud, because sometimes that seems to be, at organizations I've worked at that consider moving to the cloud, there seems to have been that trend, like we're going to be on, cloud platforms and microservices and all that. And let's just kind of look at some of the problems, because I've been part of these monolith to microservice transitions. So like we had this whole big monolith, and we did this architecturing, and we're like saying like, okay, we have orders, items, order history, addresses, fulfillment, and users. And then we architected to where like orders kind of has control over addresses and fulfillment. User kind of has control over order history and items. I just kind of put this together. Maybe it doesn't make total sense, but like, maybe in this architecture diagram, this is just a way we kind of decided to write it out because it made sense maybe from that perspective. But then when you actually and then of course like user and orders, like they would communicate with one another to get then, a user would talk with orders, and then that would go down to addresses. Like that's like the architected line of communications. And then kind of with that, then we would kind of deploy these things on different machines or in different areas of our organization. So orders, addresses, fulfillment, they would all be located on a machine, because again, in the architecture diagram, like those would be communicating with each other a whole lot, whereas the communications between then with items, order, history, and user would be less, so they could be located on a separate machine. But in reality, as maybe the applications actually really developed, or as business needs and requirements expand, developers are like, oh, I just really need to get from items to orders, because, well, that kind of maybe makes sense. Of course, items would need to talk to orders or something like that. So they kind of poke a hole through that, and so they're talking to that. And user would need to talk to address and fulfillment. So like, holes are kind of done to do that. And so now everything's kind of talking to all these different things. And really the communication from like user to order doesn't make much sense. So maybe the actual bounded context, would have actually been like this, whereas the architecture kind of had it like set up like this. So, but what you kind of end up here in this case is a distributed monolith that really everything's kind of talking to each other. They're all pretty related, but now they're spread across in all these different deployments on all these different machines. And whereas if you had this deployed as a single artifact, as a single monolith, it wouldn't be so bad to be crossing all these different communication boundaries, because it's all running in a single process in a single location. When you actually have this distributed across many services and many different regions, this becomes very expensive. It becomes very expensive when the item service has to talk to the orders service often, because when the item service is calling there, it has to set up an HTTP connection, or maybe it's a message event. If you're doing like event-driven architecture, then it has to serialize its message. Orders then has to deserialize it, do whatever it's processing it needs to do, then either send back a response or send out another message and deserialize it, and then pick that up by items. So calls between individual microservices become a whole lot more expensive than when they are within a single monolith. This isn't an argument against doing microservices. Again, there are very good reasons to do it, but it's also, you just kind of have to know what you're doing with it, and you just want to make sure as you're doing that, you're doing it like organically finding areas where it makes sense. And a lot of this presentation could be then also a way on, if you want to do microservices, how to do that first, kind of by building really good observability. But yeah, I kind of touched it. Yeah, some of the challenges, distributed systems have emerging problems. Also, microservices often require organizational change. If you have a team that has control over a microservice, they need to have that full control to deploy it whenever they want, to make any changes they want, and so on. And a lot of organizations just aren't ready to do that. They have the application team, they have like a database team, they have an ops team, and they all have separate kind of reporting structures, so you don't have that flexibility to kind of deploy whenever you would like to. Also, finally, you also really need to have like a deep understanding of domain-driven design, DDD, and your domain. And that just sometimes just takes time and work to get to that level, because it requires to learn two things instead of one. So necessarily it's just going to be a bit less when both people have that kind of knowledge. Also, with monoliths, there's this idea that monoliths just are this old busted thing, and you can't do anything cool with them. But no, you can use Spring Boot. There's no size limit to a Spring Boot application. You could have as big of an application as you want running on Spring Boot. So there's no reason you have to be using old Apache struts when you're using monoliths or something like that. Also, you can do things like continuous integration and continuous delivery. You need to do continuous integration and continuous delivery to be successful with microservices, but they're just as relevant within a monolithic world as well, because you still benefit from that automation, that auditability, that reproducibility that you get with an automated delivery pipeline that you get from continuous integration and continuous delivery. So yeah, we're kind of moving on to the cloud. And so kind of maybe once you get to the cloud, there's a lot of benefits you get from running on cloud providers. And one of them is they have a lot of available services out there for monitoring and doing various things. And you should definitely take advantage of them. And I kind of just particularly take on monitoring and like logging just because I worked as a consultant before I became a developer advocate. And I remember I was doing part of like a microservices transition and just kind of getting good monitoring systems set up and good logging systems set up can actually take quite a bit of time. It might sound easy, it might sound commonly done, and to some degree it is, but it can still be very time consuming. It can take a lot of developer hours to it. And optimization isn't always just about the system itself, it's also about the organization and how we can use our developer hours efficiently. So all the cloud providers, whether it's IBM Cloud, AWS, Azure, they all have a huge amount of services already available for addressing a lot of common needs, whether it's database, you know, kind of already just have it here highlighted. Like, I know just because I just most experience with it, like IBM, you know, we have like logging options where it's a few simple commands, and just like that, you have logging and monitoring up and running without having to do too much work. You may have to do some tweaking as well to get maybe more information that you particularly are interested in, but the amount of time you're taking to get that to happen is just, it's, you know, instead of weeks or even months of developer effort, it's, you know, an hour. So that can save an organization a lot of time, a lot of money, a lot of frustration. So definitely make sure if you're moving to a cloud provider, you kind of get out of that not invented here syndrome, that you'll actually really start taking advantage of those cloud offerings. And also cloud offerings even have like third-party offerings. If you don't want to use some of the built-in stuff that AWS, Azure, IBM Cloud, GCP have, you still have like Datadog stuff that also kind of integrate with those clouds as well. So even if you're doing a monolith, though, often any monolith I've worked with still kind of at some point calls out to other services. And especially though, if you're doing a microservice though, like it can be very difficult to correlate those requests. So you have your client come in, they make a request to one service, and then they will request maybe down to like another service, and maybe it goes on to a third service as well. And I remember from very painful experiences, sometimes having to try to manually correlate those logs and try to figure out, you know, what went wrong with an error or something like that to see like what values, like how did this null get down to like this way deep down service that's never happened, and then you find out, you know, you have to correlate it back up through the chain. It's difficult, it's time consuming, it's painful, and of course, as you get to more and more services and more requests, it becomes extremely difficult to actually do that effectively and just very time consuming. So if you're using Spring Boot and kind of using it throughout, you can use Spring Cloud Sleuth to handle a lot of the request tracing and correlation. And really all you need to do to actually get it to work is you just need to pass in Spring Cloud Sleuth Starter and Spring Cloud Starter Zipkin. And so Spring Cloud Sleuth, what it does is it puts a couple of values in request headers, a couple of IDs, a span ID and a trace ID. So the span ID are, sorry about that. So the span ID is the ID, or the trace ID, sorry, is a trace ID is the ID that covers the entire request through your entire system. So this is the trace ID, and despite it going through 4 different services, it has the same ID throughout, so you can easily correlate it in your logs where hopefully they're all being aggregated. Then you have the span ID. The span ID covers all the requests within an individual service. So here we have like the 2485 ID, and that's correlated to this service number 1. So every action request or every logging event attached with this request within service 1 will have this ID. You can see the service 2 where it kind of, again, has the same ID throughout. So it just makes it very quick and easy to track down all the logging events associated with a specific request or a specific request within a service. And except all you have to do to get that is to put this dependency within your Maven file, or if you're using Gradle, just using the correct syntax for that. Then there's also correlation, which we're going to look at, or tracing, which we're going to look at with Zipkin. So I have it a little bit backwards, but correlation refers to Sleuth, and then tracing is Zipkin. So what is request tracing? So request tracing is timing how it's taking a sample of requests. By default, it's 10% of all requests. But you can change it to 0% if you don't want to do any tracing, or of course 100% if you want to trace everything. Of course, there's some amount of CPU associated with it, so you wouldn't want to have it at too high percent or even totally off if you really just don't need to be capturing information. But I was saying, what it does is it takes it, and in this case it's using Zipkin, to kind of time the different requests. And what's important here is it can help you know where to spend your time optimization. So if you were to look at this request, if you're just looking at the logs, you would see like, oh, it's making a lot of connections. I think it's 2. I thought there was 3 in here, but like it's 2 or 3. Let's just say it was calling MySQL DB connect a bunch of times. But if you look at these requests, it's only taking 605 microseconds to connect to MySQL. So really, if you completely zero out these times that these requests took no time whatsoever, you wouldn't really save much time by actually optimizing them. Whereas this select statement here, and this get, well, these are taking a lot of time. This is taking 54 milliseconds and 40 milliseconds. So spending time on how you can improve and optimize these select statements would actually be time really well spent on actually improving the performance, or at least the request time on your application. So this select, or this timing stuff, can just kind of say where you should be actually spending your time optimizing an application is kind of where I'm getting at with this. Google, they do a lot of white papers, and kind of like where this concept of tracing came from is a white paper called Project Dapper. And it's kind of like how Google spent time trying to optimize their applications, and again, how they figured out where they should be spending their time versus where they shouldn't be spending time. So that could be, if you think this is something really interesting, definitely check out that white paper. It's like 10 pages, so it's not too long to read. So from there, another thing where you can just pretty much just drop in a dependency and get a lot of the benefit is use and customize the Spring Boot Actuator. This is another good way to get good metrics and observability out of your application. And just by default, Spring Boot Actuator offers the health endpoint, the info endpoint. There's also now metrics, and then also can send out information to Prometheus, like what sort of configuration properties. And there's a whole lot more. And you can check out here just to see all the different endpoints that they have available. And so a lot of this stuff is pre-configured pretty well. It has pretty good auto configuration and good opinions of how this stuff should be set up. But you may also need to customize it. So by default, health will scan for various data sources and caches within your application context. And as long as those are all healthy and good, it will report back a 200 state of healthy, or 200 HTTP response status. They can also be customized. If hypothetically a service you have depends on some downstream service, and that downstream service, if it's down, then you consider this upstream service down as well for whatever reason. That's maybe not the greatest example, but let's just accept that for what it is. You can also write a custom health indicator like this, where, again, you kind of see I'm just making a REST template call or HTTP request call down to like this dependent service actuator health, and if it's turning back to 200, then it aggregates it and then it returns to 200. But if this is returning to 500, then the servers return a down status as well. So you might want to customize it as well, just depending upon, again, your needs of your organization or that particular service that maybe it needs to check something else to determine its health status. Something that's new, though, also in Spring Boot 2.3.0 is they added liveliness and readiness probes. And this is something that's kind of very much related to the increasing popularity of deploying Spring Boot on Kubernetes or just in a containerized environment. So liveliness is the service still in a functional state? So sometimes over time, services might just get into a failed state. Maybe there's like an issue in its thread pooling to where thread pools or threads go bad and they're not refreshed. I think we've all done that at one point in our careers where we've actually implemented a thread pool incorrectly. At least I know I've done that a couple of times. So this leveliness pool can be checked to say, like, is this thing correct or is this still alive? And if it isn't, then whether it's Kubernetes or some other service can kill that instance of it and then start a new one up if this liveliness is reporting dead. Readiness is somewhat similar, but it's distinct as well, and that is a service and it's in a state, is a service in a state that can process transactions. So, so it's a service that is in the state to ready to process transactions. So maybe a service, when it's starting up, it's getting it's connected out to the database or doing other things like that. So it may not be immediately ready to process transactions. So it may take a few seconds, or it could be a case where the database becomes overloaded and it's not currently able to process transactions. It's just really important to remember, though, that readiness is not equal to liveliness. I think sometimes. I probably shouldn't have had this first explanation pointing in there because now it's like not readiness. Sorry about that. But yeah, readiness is not equal to liveliness, that they are two distinct concepts. I'm actually going to get a little bit more into that in these two next concepts. But when something's not ready, it just means it might get ready again. It might just be temporarily overloaded and it's just being held off from getting any more things out. Whereas liveliness, like I said, it's just maybe the state's in an irrecoverable state. But you also want to make sure you don't want to have liveliness tied to some downstream service too much, because if like a downstream database goes down, you don't want all of your upstream services to also go down with it, because that could lead to what's called a cascading failure. And like I said, we're going to talk about that here in these next couple of points, and I can kind of give examples of that. So the first one would be kind of maybe around optimizing for resiliency also then, as well as we're kind of getting into this topic, is using pools to meter resource usage. So again, like let's say you have a service that's talking to a downstream database and you're not really having any way of metering that usage, you might eventually overwhelm that database, it crashes, and then the downstream service crashes with it. And this is kind of where also liveliness can be useful. If again, like your database goes down and you have your liveliness probe attached to your database state, you don't want to have, when your database goes down, all your other services attached to it to also have to be stopped and restarted, because that's just going to cause a whole lot of other issues. It could cause like what's called a cascading failure. But also going back to pools to many resource usage, over time, if you might find out like, okay, I mean, it's really low. Like, let's say just your database can't take more than 5 or 6 concurrent requests. Instead of then sending the 7th request and crashing your database, what you can do is either have that 7th request that's just kicked out until those other 6 requests have finished processing, or you can also have it put into a queue for some amount of time, saying like, okay, you're going to wait 5 seconds, 1 second, 5 seconds, 15 seconds, whatever makes sense. And then we're going to try processing again. And then, from there, maybe that person's kicked out. They continue waiting a bit longer, or whatever it might be. But you want to kind of have you do these things instead of, again, overwhelming some downstream service. It's better to then give a person like an immediate response saying like, hold on, the services aren't able to process right now, so you're just going to wait and come back later. Which, maybe just hitting the refresh button, or you just have it wait a few seconds. Again, most of the time it's not going to be waiting for too long. It could be like 500 milliseconds or, some sort of amount of time, because again, the client's going to be waiting for this to complete before you maybe kick out the request or have something happen. Another thing kind of similar to this readiness concept is also like using circuit breakers to limit cascading failures. So, you have your database go down, and then rather than having an upstream services continually to make requests, those failing, and then eventually it goes up in flames. If this is a little bit old here, but like you can use Hystrix, and I think it's now resiliency for J, where you can have it do some sort of fallback action. And I think a common, or at least kind of scenario example I use is like where Hystrix came from and resiliency for J came from is Netflix. Is instead of maybe using the recommendation engine, which is customized based upon what an individual user is trying to get for like movies or whatever it might be, it can just do whatever's popular based upon like the geographical area you are in as a fallback in case like that recommendation engine is down. So like there could be reasonable fallbacks, but even there's no reasonable fallback other than an error, it's better to send back a quick error than like a slow error to your user, because then the user might just end up hitting refresh a whole lot of times, and then that might just completely overwhelm other parts of your system and then cause further failures. It can be good to be stateless as much as possible. Stateless can help a lot when it comes to scalability and also resiliency. So if for whatever reason, as we were kind of talking about a little bit earlier with the liveliness probe or the readiness probe, if at some point one instance becomes either overwhelmed or crashes, then if you're stateless, a user can just easily go to like a different instance and they wouldn't be any the wiser that anything's going on. Similarly, if you need to scale up really quickly, you can easily then start sending users to those new instances without having to keep them attached to some instance because of state that's being held in session. And as also you need to scale down, you can also kill off instances with pretty much ease without having to worry about losing too much state. Actually, one other thing I want to touch on with that, another thing that's kind of new in Spring Boot 2.3 is what they have is a graceful shutdown period. And so you can just create a period to where when the container gets a kill signal, you can have it, wait whatever amount of time, a few seconds, a few milliseconds, whatever makes sense for that application, so it can finish up processing any currently in-flight transactions before actually shutting down totally. So that way users, if they're connected to some sort of instance or some sort of request is processing, they're not going to get back a 500 because the instance gets shut down before it's finished processing. So that's another thing that's added in Spring Boot 2.3 is the graceful shutdown period. So getting to one of the areas that I find really interesting, particularly at the automation perspective, is automated testing. And one really cool thing to use for that is Spring Cloud Contracts. You can validate contracts between different services. In this example, I'm using HTTP, but you can also do it with advanced messaging. But pretty much it's like, by default, like a lot of times when you want to do integration testing between services, a lot of times what you do is you actually connect to the live service, like in a development instance. And generally that can work fine. But what can happen, though, is that maybe development instance, again, crashes, is brought down for some other odd reason. And so when you run that test again, it fails, but it's not failing because anything changed in this contract or this API. It's just failing because that person service was down at that point. And so that test fails. So it's not really giving you good information about the state of your application with regards to its compatibility. It's just failing for some odd reason. So you can write contracts. I have a whole presentation about this, so I won't get too much in depth to it. But pretty much you just contracts, you write out what's supposed to happen, what's the interaction supposed to happen between these services. And so now, instead of then actually having to connect to an actual live service, you can connect to a local instance of that, and that test should always succeed. And then whatever service that this represents can also test against this contract to make sure it's meeting as well. So you know that the contract actually represents what would be the reality in production. So that's really nice. And it's just should execute a lot more quickly and a lot more consistently, successfully. So there's also similarly for test container, not everything can be covered by HTTP request or event messaging. So in that case, you also have test containers. And test containers is a framework for the JUnit, which can spin up and tear down Docker containers within the lifecycle of a unit test. And so exact same concept. If you're talking to a dev database, data may go missing, the database may go down, whatever reason, causes your test to fail. So instead, you can create an instance of that Docker or that database in a Docker container, and then have test containers spin it up and spin it out within the lifecycle of tests. So that way, your test should always fail. You're not going to have to worry too much about data going missing or that database being down. So with these improvements to your automated testing, you can actually start maybe consider setting up a continuous delivery pipeline to production. So you can have your developers, they commit code to whatever your code repository, and then whenever that commit happens, well, then that kicks off a build process to your build server. It will run through its automated checks. Of course, there's automated testing is probably the biggest one, but you can have vulnerability analysis, other kind of checks to make sure things are looking good, and then from there, either have it either pushed right out to production at that moment, or you can maybe have some sort of near production state that can be pushed later at some other time, again, depending upon your organization's needs. Another thing that's kind of getting into a little bit with some of my work is you also could consider how you tune your deployment into production, because that can be a time where if you're just pushing things out there without really much consideration, you can cause a lot of havoc or cause a lot of expense. So some considerations when deploying to production is resource usage, disruption to clients, and then the speed of deployment. So, I guess maybe all that's running within this then is also cost. So, you can have really low resource usage. You can have high resource usage and really fast deployment. Of course, it's going to cost a lot more. Whereas if you do really low resource usage, it's probably going to increase how long it takes for a deployment to complete, but it'll be also then cheaper. So kind of like cost is kind of like a thing that overall you can be maybe thinking about when also deployment as well. But there's two major strategies. One, this is kind of taken from Kubernetes, but this would also just be a case for kind of anything if you're not using Kubernetes. One would be a rolling update where end instances are started and stopped before going to the next group. So you could say you have 10 instances. Okay, we're going to start 2, get them spun up. Once it's spun up, we're going to kill 2 and then start going to sending traffic to those new 2 instances. And then we're going to do that 5 times until all the new instances are up and all the old instances are gone. Obviously, a rolling update can take longer. It's a little bit slower, but it's also a little bit less disruptive. You're not going to have to spin up a whole bunch of instances at the same time as well. Another one would be what's called like a recreate, where if you have 10 instances available, but then you start up 10 instances and then, you start going traffic to them and then you kill those 10 instances. Doing a recreate would, be either more disruptive, it would probably be faster, but it will also, again, kind of have more resource usage because you may be running, 2 whole entire production instances for some amount of time, probably only be a few seconds, maybe a couple of minutes, but that will be a lot more resource usage than maybe doing like a rolling update would be. But how you handle deployment, that can change depending upon the individual severity of changes and also individual deployments. So maybe you release every single night and generally it's low impact. Okay, yeah, I'll get to that question in just a second. Actually, sorry, I'll just go ahead and get to that now. So I just got a question from Request about test containers. And so yes, it would be entirely for dependent systems like databases, caching service, or anything that can't maybe perhaps be covered by a contract test. You can also have it covered by things that are like a RESTful API request if you wanted to. Just you would definitely need it in this case. But yeah, you could cover any of those kind of tests in there within those kind of those kinds of integration tests, and yeah, are within those kind of constraints. Now, in that case, yeah, it would be called an integration test rather than unit test. But it just would still be, it could still be run under JUnit. You just maybe have it run as part of the let's see, I think it's fail-safe lifecycle, the integration testing lifecycle instead of the CERFA or unit test automated testing cycle. So yeah, let me know if you have any questions though. That was a good question. So back to tuning your deployment to production, how you can handle, or so how you would also deploy to production. You wouldn't also, it would be kind of like the optimization thing where you wouldn't just set it and then just let it kind of, or do that kind of deployment every single time. Let's say you're typically deploying nightly every time. You may just, in that case, do like a slow rolling update because, you know, maybe it's only minor changes between each individual time. So you don't really need to have like a very fast deployment out there because it's not going to matter too much if a user is going to an older instance or a new instance. However, if there's like maybe some sort of major regulatory change, like something that has to happen, you know, right on July 21st, you know, then you may have to do a recreate where on that day, all the old instances right at, you know, 11:59 p.m. on July 20th go down, and then all the new instances have to come up at 12 a.m. So, you know, that how you deploy to production could change between individual deployments. But, you know, kind of also as we are now automating our deployments to production, we have all these automated checking. One important thing also then is being able to keep our dependencies up to date. This is something that a lot of organizations I worked at as a consultant just had a lot of trouble doing. And there can just be this misperception that, you know, as developers, we're constantly working every day on our code and we're pushing out to production. And we think that the code that we're actually pushing out to production represents a majority of the actual code that's running out in production, but really it's kind of like an iceberg. It's just the very tip of the iceberg of what we're working on. Because, you know, here's our first party, whether it's a monolith or a microservices up here, and then here's all the code our code runs on, you know, Spring Boot, you know, Jakarta stuff, Java, like the JDK, whatever operating system, you know, all this stuff exists down here, and here comes oops, sorry about that. Security patches. So going back to that Equifax hack I talked about at the start of the presentation, what was actually exploited by the hackers in the Equifax case, it wasn't the first party Equifax code, it was an exploit in Apache struts, but by the time that code was exploited, actually Apache struts had already released a fix and patch for that. It's just that Equifax wasn't to bring that in time. And that's no doubt because they probably had a very manual deployment process where there was a lot of fear and uncertainty when it comes to even bringing in a patch change because you just don't know what it's going to do because you don't have a good automated process to say like, oh, okay, if we update from Spring Boot 2.3.1 to Spring Boot 2.3.2, we don't know what's going to happen. But if you have a bunch of automated tests, you can quickly find out like, okay, yep, this isn't going to cause any major issues. Just bring it in. And maybe it does cause an issue, but then it can be pretty easy to fix that and then push out the change to that without, again, kind of getting into a cycle of maybe where you're constantly maybe having a whole lot of breaks and having to do a lot of emergency releases. So that's kind of some of the benefit from automation there. Of course, also, there could be performance enhancements and feature enhancements. This can be annoying if you are working on this really old application and it's like it's still running, it's not even on Spring Boot. Like maybe you're on, you know, Spring 3.x, which is it supported anymore, and then you're not being able to take advantage of like any other really cool features that came out in Spring or whatever kind of framework you're using, because you can't update it without risk of maybe causing some sort of major production outage. Another thing to consider is switching to OpenJ9 for running your JVM. So for a lot of organizations, for a lot of developers, they're just running JVM, and it's probably hotspot because that's just default. It makes up probably about 90 or so % of the market, and you just don't think much about it. But actually, OpenJ9, it is part of the Eclipse organization, but IBM helps support and does a lot of the majority of coding on it, but it's completely open source. But you can save a huge amount of memory. So I put together a really simple like Spring Boot batch application. And kind of what I see and what some of our customers have seen when running this is like you get a pretty substantial, about 40% memory savings when compared to running on hotspot. And it also executes, like the throughput is roughly about the same. So that is actually really nice. And again, you don't really have to make any changes to take advantage of this. But like in this case, I'm running the exact same Java artifact across all these different JVMs, including like Amazon's Korando, which is again based on hotspot. So that's kind of why they run very similarly. Like I said, memory savings about 40%, near same throughput usage. It's completely and totally free to use. It's licensed under the public license 2.0 and the Apache license 2.0. And actually, I think I need to update this, but you can find more about it at the adoptopenjdk.net, which is actually now becoming Adoptium. Also, this is actually something that I know in newer versions of Hotspot is also better supported, but what's also called class file sharing. So this isn't typically a great way to store class information. You're storing both dynamic and static information in here. So in OpenJ9, this is split into stuff that's like read-only memory, like static information, like the class name, field names, and stuff like that. That's going to be, of course, the same across every instance of that class, across all the JVMs. But then there's going to be the dynamic information, like the actual value associated with a particular field name or something like that. So OpenJ9 splits that into two parts. It's the read-only, persistent-independent, and then the stateful part. And so when you see it across many JVMs, you can kind of see where this advantage can come into place. Instead of having every single JVM, when it spins up, recreate this identical information, you can just share it across them, and that can save a lot of CPU and then, of course, also startup time. It can be simply started by adding X share classes, and then also setting like how big that default cache size is. And there's also some ways. I wrote an article a little while back on how to do class sharing in a Dockerized environment, because kind of that's what we're talking about in this presentation is probably doing a lot of this stuff in a containerized world. And so there's ways where when you first build that image, you kind of pre-populate the cache. So then when it actually starts up in a production use case or, on your actual Kubernetes cluster, that class is already pre-populated. And again, that kind of saves you startup time. Also, to consider using Spring Cloud has the Spring Cloud config server. So instead of actually having to restart the instance of your applications to make some sort of configuration change, you can instead use a config server where your application will, you can make an update to config server and your config client, and then your config server will pick up that change. And then like every so once in a while, I think the default is 5 minutes for it. The config client will check the config server to see if anything has changed. If something has changed, the config or the client that is reading that in, pick up that change and then restart the application context to actually then take that change in. So it's a way of, I guess, having at least minimal downtime where you don't actually have to do a restart just to make some sort of configuration change. And again, that can be also very helpful when it comes to optimization, where you might say for like your pooling, your database connection pooling, like what happens if we increase the pool by some amount? Can our database handle it? Does it crash? What if we change like how long the queue length is? And various things, you kind of make some changes that they config, and it'd be very low cost to make that change just to see how it actually behaves in production. Also, definitely consider tuning your Spring Boot application. There's a lot of relatively simple things you can do, like you can explode your jar. So if you're running in a containerized environment, it's the only thing that's running in there. So there's no real problem in just unzipping it and just having it run. And that can save a little bit of startup because a jar is just a zipped up compressed application folder. You can also review which features you're using. So I talked about earlier about using Actuator, but maybe you're not really needing to get too much observability out of your application. So you consider just maybe shutting it off. Again, that can save you time for startup. There's also like turning off JMX, which can start up time, and then just also maybe save you some time or CPU time just from the overhead from JMX. Excluding any dependencies you might not be using. Some of them could also be replacing certain dependencies. I believe JSON actually has some advantages from performance perspective over Jackson, which is a default. So you can consider switching those out if needed. Also, the Spring Boot team, kind of talking about the dependencies issues from earlier, they're always kind of looking on how to improve the performance for Spring. So if you're on the latest version of Spring, you can always kind of take in some improved performance that way. Also consider tuning your JVM. Also, you can do like no verify, which will again save a little bit of time to startup and also a little bit on CPU. Also, maybe consider lazy loading things if you don't read them right at startup. But Dave Sire with the Pivotal team or the Spring team, he kind of did these different checks. Again, this is a little bit from ago because this is using Spring Boot 2.0 and then 2.1 as comparisons. But I think one of the things that's really interesting in this example is just a very simple Hello World Spring Web RESTful application. But there's this idea, I think, sometimes that Spring Boot is like super memory hungry just because it kind of works so easily. It's like, oh, okay, you know, if it's doing work this easily, well, then it must take a lot of memory or be really resource hungry. But as you can kind of see here, you could get it down to where, you know, it's probably maybe about 20 or 30 megabytes of heap size before the load times just kind of go off into infinite because it can't actually load. So actually Spring Boot doesn't need a whole lot of memory to run. But definitely check out these articles and these presentations that Dave Sire had gave on this because they're very useful and maybe some ways to tune your Spring Boot application. I've actually kind of done this a couple of times as well when working with some of our clients. Definitely consider A/B testing. So A/B testing is simply having both available instances of an application out there with, you know, whatever different optimization changes in this case you have, and then just seeing how either of them behave and just kind of randomly sending client requests to the different ones. So, you know, you have A and B here and like, oh, okay, you know, B is clearly running a whole lot faster than A. So that gives you an idea that, okay, this change is actually much faster. Whereas if you just have those requests running at different times, then you can't always be sure, is it a request or is the service actually running faster, or is just the load different or the request a little bit different at this time of day? So this can be a good way to actually test and tune your performance and to make sure the optimization changes you're making are the right ones. And then, okay, so and then the last one, consider introducing chaos into production. So Netflix, they released a few years back a service called Chaos Monkey, where it would randomly go and crash different services at different times of the day. And you would do it, you know, 10:30 a.m., you know, during working hours. And this way you would just know, like, okay, from like earlier, you set up, you know, circuit breakers, liveness probes, readiness probes, all these different things to say, like, if this database goes down, then, you know, you should have things that can just recover for it without their clients actually knowing. But you don't actually know that until you actually bring that database down to see if it does happen. You know, does the service here say like, hey, this is down, I'm going to stop sending requests to it, and then this is going to get restarted? Does that actually happen? And so sometimes you just need to actually test that, you know, the emergency plan out to make sure those things actually happen. You know, what if something else also goes down? Again, does your system recover? Better to have that happen, you know, when everyone's there than at, you know, 2 o'clock in the morning when someone just gets pagered and saying like, hey, production's on fire, find out what happens, and then, you know, that's not really great for anyone. So just review, here's all the different 18 options or 18 things we went over. And also be sure to send this slide deck to Mary. Actually, I need to update this. I added a new one. So you can check out this slide deck later on. So are there any questions then? And also at this point, feel free just to actually unmute yourself and ask a question.
A quiet bunch.
Yeah.
Hey, this is Rakesh.
Oh, hey.
I have a question on the class sharing that you showed. Is the J9 an IBM JVM or what is it? Also, when you say class sharing, is it a remote call from all the JVMs that they're sharing the same class? Or can you explain more on that, please?
Absolutely. So OpenJ9, it was originally built by some other team, and then IBM bought that company out. So IBM supports it, and so it's under the Eclipse Foundation, but like IBM provides the most code to it. So it's just kind of like how Hotspot's like also open source, but Oracle is the main driving force behind it. That's the kind of same case with OpenJ9. And also with the name, it's a terrible name. We kind of keep talking about changing it, but it also has nothing to do with Java 9. So you can run it on any instance of Java, Java 8, or to the most recent Java 14 and 15 coming out here eventually. To the question of class sharing. So how that works is actually a pretty good system set up where it actually just writes to a file directory. So the first JVM instance that has to compile the class, it'll just compile it, and then it'll just write to this directory, and then all the other JVMs that are using that class sharing will just read from that directory and say like, oh, okay, I need this class, and using hashing or whatever, say like, is this available in this class sharing? Yes, okay, it'll just grab it and then load that class in instead. So it can be local calls always. It's not having to make a necessarily remote call out there to get that class sharing. There is a thing called JIT as a service that we're working on, which would be in that case a remote call. But I don't want to get too much into that just because I know we're always kind of running out of time as well. But if you want, I can kind of get into more details on that as well. If you want to send me an email, I'll be happy to answer questions in more detail.
No, I think this is good. Yeah, thank you. Thanks.
Yeah, absolutely. Any other questions? All right. Well, if you have any questions, like I said, don't hesitate. Feel free to send me a DM on Twitter, or you can email me at william.korando@IBM, and I'll be happy to answer any questions that you might have. All right. Thank you very much.
Well, maybe, no more questions. So thank you. I really appreciate you spending your time tonight talking about Spring Boot on the cloud.